Good morning, this is Mrs. Dubois, and today we're going to talk about revisit systems of equations, solving systems of equations using substitution. All right, and in the beginning, we have a few clever examples using numbers, binomials, and shapes. So, in the first pre-example, if x is equal to 2 and y is equal to 3, we can simply, all we're doing is rewriting this and plugging in. We don't need to solve, we're just plugging in. In the second pre-example, we have x is equal to a star and y is equal to a moon. And again, we are just plugging in or substituting for the variables. And in the last one, we have an expression to plug in. So we have 2z plus 1 plus 3 p minus 4 equals 20. For the next 3 examples, we're going to solve them, and then you can check your answer on Desmos. So we are using substitution. So you want to choose the variable that's by itself. See how y is alone by itself? You want to substitute in 6x for y. I need to move that over a bit. Otherwise, I'll never fit all 3 on this paper. Trying to figure out a better way. All right, let me move this one over. Move it over here. So I have 2x plus 3 times 6x equals negative 20. Now I evaluate this. 2x plus 18x equals negative 20. Draw my line. Combine like terms. X is equal to negative 1. You want to divide each side by 20. Now you're going to plug in negative 1 into here. So you'll have 2x plus 3y equals negative 20. Actually, even a better choice right here would be to plug x is equal to 1 into the other equation, the top equation. Sorry about that. So let's do it over here. Y equals 6 times negative 1. So y equals negative 6. So your answer here is negative 1, negative 6. Now up here, again, we have x alone, right? So we're going to plug in 3y where we see x. So 3 times 3y minus 5y equals 12. So then when we evaluate 9y minus 5y equals 12, we'll have 4y equals 12. And divide by 4. And y equals 3. And now you can do the same thing. Y equals 3. Go back up to this equation. X is equal to 3 times 3, which is 9. This is 9. Just double checking some of the answers there. Sorry. All right. So now, okay. Hoping I just edited that right. Okay. So now we have x equals something. and x equals something. So in this one, we can actually set the two equations equal to each other. So now I have my two equations equal to each other. I can get my y's on one side, subtract y from each side. You'll have y plus 7 equals 4. Then you want to subtract 7, so you'll have y is equal to negative 3. And then, so I'm going to put my negative 3 here. Then I'm going to plug back in. So I'll have x is equal to 2 times negative 3 plus 7. So that is negative 6 plus 7. So that is 1. And we can test that out to 2 up here times negative 3. Yeah, it's negative 6. That will give you negative 1. So 1, negative 3 is the solution. And you can check those on Desmos. It's a good idea to check them on Desmos. All right, I'm going to do a couple more with you. And then I'm going to have you practice a couple on yourself, by yourselves. Okay, again, this one, the y's are equal. So you want to set them equal to each other. Then you want to gather all the x's on one side. So you have x minus 2 equals 2, x equals 4. Now you're going to plug back in, right? Y equals 4 plus 2, so that is 6. So your ordered pair is 4, 6. And I'm just checking that would be 8. Yeah, and that does in fact work. Okay. And then I'm going to do 5, right? And again, you have one variable on one side. So for y, you're going to plug in. So you're going to have y. I'm going to undo that fact, because I'm going to start with the second equation there. Okay, so we're going to plug in 2x minus 2x plus 6 equals y. Equals 2, sorry. Now you have to distribute this negative 1 right here. So you're going to have 2x minus 2x minus 6 equals 2. So that gives you negative 6 equals 2. Ooh, that looks like no solution. What I'm going to do is I'm going to take that one, double check, and take that one out to Desmos to see. Hold on. All right, we're in business. I took this one out to Desmos, and they are in fact parallel lines. So there's no solution here. All right, because a few of these look a little tricky. All right, let's approach the next one. What I would do is shut this off and try through 9 and then check back to see if you have the right answers. So this one, y is alone by itself, so I'm going to plug y into the top equation. So you have 3x plus negative x minus 2 equals 12. Then I'm going to combine everything, simplify the left, nothing to simplify on the right. So you have 2x equals 14 and x equals 7. So x is equal to 7. So then I'm going to plug x back into the first one. It shouldn't really matter. 3 times 7 plus y equals 12. So draw my line. So you have 21 plus y equals 12. Y equals negative 9. And yeah, that does check out. This would be 21. This one would be negative 7. Yeah, well, that does work in both of them. Okay, so now I told you to look for one that has the variable alone, but if you notice in number 7, none of them are. All right, if you notice in number 7, none of them have the variable by themselves. So you have to solve for the variable first. So I'm going to choose this one because the coefficient on x is 1. So I'll have x equals negative 2y plus 13. And then I'm going to plug that in to the second equation. So I'll have negative 2y plus 13 minus 3y equals negative 18. Whoosh. So draw your line to keep yourself organized. So you'll have 4y minus 26 minus 3y equals negative 18. So simplify the left, we'll have y minus 26 equals negative 18. Then I'm going to add 26 to each side because you add the opposite to go from one side to the other. And so y is equal to 8. Okay, y is equal to 8, and then you want to plug in, I go to green. Can I write over here x plus 2 times 8 equals 13. X plus 16 equals 13. So if I draw my line and subtract 16, I'm going to get x is equal to negative 3. And that is negative 3. Woohoo! All right. Okay. All right. And so this one too, I'm going to select this one because the coefficient on x is 1. So if I solve this for x by itself, I'm going to get 5y plus 36. Then I'm going to plug that x into the top equation. So I get 2, 5y plus 36 plus y equals negative 16. So you get 10y plus 72 plus y equals negative 16. So 11y plus 72 equals negative 16. Woo. Now we're going to subtract 72. Oh, well, that comes out nicely. You get 11y equals negative 88. So y is negative 8. And then if you plug it back up into here, you're going to get 2x minus 8 equals negative 16. So you get y is equal to negative 4. And I'm going to plug those calculations back in. 2x plus y equals negative 16. So again, I would complete these and then either check them out on Desmos so you know, excuse me, whether you're coming up with the right answer or not. Yeah, negative 4, negative 8. We're in business. Okay, number 9. So again, this has a coefficient of 1, right? So I'm going to pick that one and solve for x. So x is going to be equal to 2y plus 3. Then I'm going to go to the second equation, plug that x value in. I can tell right up front there's going to be some distributing here. So 8y plus 12 minus 8y equals 12. Oh, nice. So when I simplify the left side, that cancels. You have 12 equals 12, which is a true statement. So there are many solutions. They're all real numbers. And you should take that one out onto Desmos and you'll see that they're parallel. All right, let's see what we have today for word problems. You begin with $10 and plan to save $2 each day. Your cousin starts with $20 and plans to save $1 each day. So I'm just double checking, right? This is where they begin. That's my B. And they're saving, so it's a positive. And so U, let's see, we're putting them in the form of y equals mx plus b. We have y equals 2x plus 10. And then we have y equals 20 plus x. I should write those both the same way. Okay. And then I'm going to use substitution to solve it. So again, you have y by itself here. So the easiest thing is to just set these two equations equal to each other. So 2x plus 10 equals x plus 20. Draw your line. You'll have x is equal to 10. And so after, by using substitution, we get x is equal to 10. And so now we'll go back. 2 times 10 plus 10. So y will equal to 20 plus 10, which is 30. So y is equal to 30. So it's 10/30, which means that after 10 days, you and your cousin will have $30. Okay. Now we're going to buy some movie tickets. Tickets to a movie cost $12 for adults and $8 for students. A group of friends purchased 4 tickets for $460. Write a systems of equations. All right. So let's do money to money to money. First of all, let's define x is equal to adult tickets, and y is going to equal student tickets. All right, so then we'll have 12x plus 8y equals 460. And it's kind of like this one goes money, $12, money to money, okay? And the other one goes adult tickets plus student tickets equals total tickets. So if you see the labels on here, like this is money to money to money. This is tickets to tickets to tickets. Now, I'm going to use substitution to solve. So I'm going to solve, the first one is x plus y equals 40. So I'm going to subtract y from each side. And I'm going to get x is equal to 40 minus y. And I'm going to substitute that in. 12 times 40 minus y plus 8y equals 460. All right. And then you need to distribute. 12 times 40 is 480. So it's 480 minus 12y plus 8y equals 460. So now I have, if I combine negative 4y minus 20, so y is equal to, when I divide each side by negative 4, 5. Okay, so now let's plug x plus y is equal to 40. X plus 5 is equal to 40. So x is equal to 35. So we'll have 35 adult and 5 child. I'm going to check that out. So 12 times 35 is 420. Plus 40 gives us 460. Yeah, that does in fact work. All right. Make sure that you show all your work and then upload this to Google Classroom, okay? So you should have work for every single variable and every single problem.